Good morning, students and parents. This is going to be our second video, Mathematics Area with Measurements, M2.2. We're going to be investigating using or determining area using a little bit more abstract thought. This is a floor tile. You probably have these in your home. Sometimes they put them on walls too. This floor tile we're going to measure with a ruler, which is another standard unit of measurement. It has inches on one side and centimeters on the other. And we're going to use inches. If we measure this floor tile, I take the 0, put it on the edge. This ruler is like a number line. I can see this floor tile is exactly 12 inches. And since it's square, it's exactly 12 inches no matter what side I move it on. Now we call 12 inches 1 foot. So this floor tile is 1 foot long. And since it's a square, it's 1 foot long on all 4 sides. Now we're going to shrink this floor tile down and imagine it being a much smaller square and use a little abstract thought to figure out the area of a room. So we're going to start thinking in the abstract. Now go ahead and follow along with me on a separate sheet of paper. I'm going to measure as best I can. It doesn't matter as long as all 4 sides are equal. Let's stay with what we're familiar with on the ruler. I'm going to use an inch. But I'm going to imagine this is that 12-inch floor tile. I'm using my abstract thought that this distance from here to here is 1 foot. So I did my square. And this would be a 1 square foot tile. I'm going to abbreviate feet FT. So this tile is 1 square foot. So now we're getting into more abstract thought. When we start making drawings of things that aren't the same size, but we're imagining them, they're either larger or smaller than what we're imagining, or what we're calculating, that's going more into abstract. Now I'm going to draw a room that I'm going to imagine is 3 feet by 4 feet. I'm not using lined paper because I don't want to confuse the squares inside the lined paper, but what we're doing now. This is feet we're using now. So I'm going to say on this side, this distance here is 3 feet. And this distance here is 4 feet. And I want to calculate how many square feet there are inside this rectangle. Now, since we're looking at this abstractly, this is not the real size of the room. This is a kind of pretend size, shrunk down. Now, we know through math we can solve this problem. We don't have to have the actual tiles to lay out. And we're going to solve it using what operation? Multiplication is correct. So I can take one factor and multiply it times another factor and get another product. I like to start with my lower factor 3, I'm going to multiply that by 4, and this is going to give me my square feet. I'm going to abbreviate it over here. 3 feet by 4 feet equals how many square feet? If you said 12, you're correct. So here's an example of taking something much larger and making a smaller model of it. Scaling it down is what we call that. And then coming up with a model of something that would be much larger, but we scaled that down and determining the square feet. This is and then added our measurement to that. This is what's required for 4th grade. So go ahead and get this, copy this onto another sheet of paper, and we'll go over some other examples. Now I've just drawn 3 random rectangles. I have no idea what the measurement of these rectangles are, but I'm going to apply my abstract understanding to solve the problem of areas for these rectangles. And I'm going to say this rectangle right here, I'm going to start with the left one, and then I'm going to go over to the right one. I'm going to write in all the measurements first, and you can follow along with me, and then if you can calculate the areas of these quicker than I can, then you're doing a good job. I'm going to say this one, this side. Now remember, we're going to be measuring standard units, even though it's not the right size. I'm going to say this over here is 8 feet on this side, and this here is 6 feet. Now this is really not an 8-foot by 6-foot rectangle. I'm imagining that it is, and now that I know how to figure out area, I don't need to have it be so concrete anymore. I can just imagine what it's supposed to be. This one here, I'm going to say is 9 feet, let's say 9 inches. 9 inches. Let's use our other standard measurement. 9 inches here. It's going to be hard for me to write over here. And 3 inches here. I'm going to turn my paper a little bit. Okay, so this is a rectangle 9 inches by 3 inches. Now we're going to take a real leap into abstraction. In your vehicle, you measure miles. There's a place on the dash where you can see how fast you're going and how many miles you've gone. A mile is a very big, very long distance, but it's still a standard measurement. I'm going to say on this one we're going to be measuring miles. So this would be almost as big as the reservation itself, or a big piece of land of the reservation. I'm using my abstract understanding to make to imagine that I'm measuring something bigger than what's actually on this piece of paper. So I'm going to say just along here is 6 miles. That may be the distance from your home to the school. Now, your home is not, the road to your school is not a perfectly straight line. It turns and turns and turns. But here, we're imagining, remember, our square footage, or our squares inside our area as rectangles. So, again, this is getting more abstract. And over here, I'm going to say this is 7 miles. Now, if the question was how many square, this would be square feet. Okay, I'm going to abbreviate squares SQ. This would be square inches. I'm going to abbreviate inches as IN. Miles, this would be, even in miles, something that big, this is going to be square miles. I'm going to put MLS. Sometimes this stands for milliliters also. So now I'm going to have to find out how many squares are in my imaginary rectangles? Feet, inches, miles. So if you remember from the previous lessons, we have two factors, and then we have our product. And this is going to be square feet. In this rectangle, we have our two factors, up, and our product. This is going to be square inches. I'm going to use the abbreviation for that. In this rectangle, we're going to have our two factors and our product. And this is going to be square miles. So pause the video, do your math, and then I'm going to go ahead and fill in these multiplication equations and come up with what the square feet, the square inches, and the square miles should be. There are my answers for how many square feet there would be in a rectangle that measures 8 feet by 6 feet. This is how many square inches would be in a rectangle that measured 3 inches by 9 inches. And I kind of left the inches out of these areas. We're shortcutting just a little bit on that. I want you to get used to writing squares, though, in the middle. If I have a measurement that measures 6 miles by 7 miles, we have 42 square miles. 42 square miles inside this rectangle. And we aren't drawing our rows and columns anymore. We're just using abstract understanding of math to be able to come up with our answers. Hope you did okay. Challenge yourself. Make some random squares, give them some random measurements. Use squares, feet, square inches, square miles, square yards, square meters. I will give you some examples of measurements on the next video.